We're entering the first of 4 factories.
This is one of the cleanest factories in the world.
How clean is clean? Even a single skin cell can actually kill one of our chips that we make here.
Chips like these. The smallest components on today's chips are smaller than the size of a virus, approximately 50,000 times smaller than the width of a human hair. And fragile as they may be, today's most expensive chips sell for upwards of $30,000 each and are reportedly transported in armored vehicles. We're talking about the massive, highly lucrative heartbeat powering the global economy.
1 trillion semiconductor devices are shipped every year. That's 100 devices for every person on Earth.
They are the foundation of economic growth around the world, and it brings together the best scientific minds to push progress forward.
The chip industry is projected to hit $1 trillion in revenue in 2026. And thanks to AI, everyone is talking about it.
Artificial intelligence boom.
My beat went from obscure backwater that people had sort of heard of to being the center of technology.
What is widely considered to be the most complex manufacturing process on Earth is facing the limitations of our physical world.
We're pushing the envelope of technology in multiple directions: software, hardware, chemistry, physics, in all dimensions.
Unprecedented market conditions.
Demand for AI infrastructure is absolutely massive. It appears to be insatiable right now.
Vulnerable choke points.
The modern economy is likely to collapse if something happens to Taiwanese chip ecosystem.
So just how resilient is the industry that requires this many layers of clothing to function?
See?
Right this way. Nestled among windmills and canals, surrounded by charming cottages and cyclists, you will find Europe's most valuable tech firm, well known for
Lithography.
The lithography tools that they create are some of the most fabulously complex and difficult to perfect machines in the world.
ASML doesn't make chips, it makes machines that make chips, and offers tech that no other company has been able to recreate. Lithography is a process that directs light through a series of mirrors, lenses, and a special blueprint to transfer patterns onto silicon wafers, essentially shrinking chip designs down to sizes invisible to the human eye, and creating the electrical pathways that give a chip its function.
All of the manufacturers of the most advanced chips in the world, whether they say it publicly or not, use ASML's machines or are about to use ASML's machines.
The nano patterning machine is one of the most critical steps in the semiconductor making. People buy new phones because they got more capabilities for the same money. So you must find a way to print much smaller features, but at much higher productivity.
In order to make the next generation of chips even more intricate, ASML literally had to develop a way to generate a type of light that does not naturally occur on Earth's surface, called EUV, extreme ultraviolet. The system is as big as a double-decker bus, weighs as much as a blue whale, and will run customers $400 million per machine. Why do your machines have to be so big?
That's a good question. First of all, as you want to print smaller resolution, you make the opening angle of the lens bigger.
Bigger lenses can collect more information to squeeze onto the surface of the chips.
The second reason is, in order to have the speed, you need very fast-moving stages.
Litho machines can repeatedly copy a pattern onto a wafer hundreds of thousands of times within about 12 seconds.
The reticle stage can move about 20 G, 4 times more acceleration than the most advanced fighter jets in the world. In order to have that power to accelerate that fast, you need big motors.
The smaller or more complex the chip, the bigger the machine needs to be. There's no avoiding it. All of the world's most advanced litho machines come from ASML. It is one hyper-specialized link in this highly concentrated supply chain that is under more pressure than ever before. All eyes are on the companies at the top and whether they're up for the challenge.
We design the semiconductor products that really drive the leading edge of compute.
This is AMD, Advanced Micro Devices. Worth more than $300 billion, it's a place where engineers fill their thermoses with liquid nitrogen. Where stock prices have been known to triple, AI is hot.
You hear it sizzle all of a sudden?
And occasionally, employees appear out of thin air.
Well, you guys are getting first-hand view of how this works. We're delivering server chips that go into supercomputers, networking chips that connect the world together, on down to the consoles that you use to play your latest games. But the common theme in all of them is they require certain compute capabilities and energy efficiency.
The switches in chips are called transistors. They're sort of like nanoscopic light switches that control the flow of electricity and generate the classic ones and zeros that ultimately make up every piece of digital information in our modern devices. Chips are everywhere. It's how your phone unlocks, your robot vacuum navigates, and how your coffee maker somehow connects to Wi-Fi. Sometimes.
When you think about the modern economy, right, and you think about how goods are produced today, what you recognize is that chips have become ubiquitous. It's very difficult to find anything that you can plug in or that runs on a battery that doesn't have a semiconductor of some form in it.
The stock market loves chips.